It just stopped. The telescope data came back, the astronomers ran the numbers 3 times, and then one of them stood up from their desk and said, "That can't be right." Before we get into this, quick question. Where in the world are you watching this right now? Drop your city in the comments. I'm genuinely curious how far across the planet this reaches. Okay, back to the star that broke everyone's calculator. What you're about to see is a star. Not just a big star, not just a record-breaking star, a star so absurdly, grotesquely enormous that when the scientific paper dropped, the astronomy community spent months just arguing about whether it was real. A star whose surface, if it replaced our sun right now, you would not find standing on Earth. You would not find it on Mars. You'd have to fly past Jupiter, keep going, and only when you were approaching the orbit of a completely different planet would you finally break through into open space. I'm going to tell you everything, the full story, the science, the scale, and the name, all of it, at the very end of this video. Because to actually feel how insane this star is, you need the context first. So stay with me. This is going to rewire how you think about what a star even is. Let me ask you something. When you picture a star, what do you picture? A dot, a point of light, maybe the sun, a big glowing ball hanging in the sky, warm and familiar. That picture is almost insultingly small for what we're talking about today, because there's a class of star out there that doesn't just dwarf the sun, it makes the sun look like a dust particle floating next to a hot air balloon. Here's the thing about stars that most people never stop to think about. A star is not just burning, it's balancing. At its core, gravity is pulling billions of tons of gas inward, crushing it so violently that atoms are ripped apart and slammed together, releasing nuclear energy that pushes back out. That tug of war, gravity in, radiation out, is the only thing keeping a star alive. The moment the balance tips, the star either explodes or collapses. No exceptions. Our sun has a radius of about 696,000 kilometers. It's burning through roughly 600 million tons of hydrogen every single second. It has been doing that for nearly 5 billion years. And yet, by the standards of the stars we're going to meet today, the sun is essentially a candle. Astronomers measure stellar sizes in solar radii. Our sun is 1. The stars on this list, their numbers start in the hundreds. They end somewhere that makes your brain quietly give up trying to picture it. But here's the thing about extremely massive stars, and this is the part that makes the whole story darker. The bigger the star, the faster it dies. The star we're building toward, it is burning through its fuel so recklessly, so violently, that it may already be in its final act. What we're looking at from 20,000 light years away might be the last gasp of the biggest thing we've ever found. You already know this one. Betelgeuse, the reddish star sitting on Orion's shoulder that's been making headlines for years because astronomers think it might be weeks or maybe centuries away from exploding. It has a radius somewhere around 700 solar radii. If you dropped it into our solar system, it would swallow Mercury, Venus, Earth, and Mars whole. Its surface would extend almost to Jupiter. That's not a star, that's a small country made of plasma, and for most of human history, it was just a dot in the sky we named after a shoulder. But here's the thing, by the time we get to where this video is going, Betelgeuse won't even make the list. Let's go bigger. W Hydrae, a red giant about 300 light years from Earth, practically next door in cosmic terms. Recent observations using the ALMA telescope produced something extraordinary, an actual resolved image of the star's surface. Not a point of light, not a fuzzy blob, a surface with features, with bright spots. Its estimated radius sits around 1,200 solar radii. At that size, it extends well past the asteroid belt. This star is so close and so well studied that we can see it aging in real time, pulsating, swelling, bleeding mass into space with every cycle. It's like watching a slow-motion explosion that's been building for 100,000 years, and it's still not the one we're here for. For years, if you searched biggest star in the universe, one name came back every single time, VY Canis Majoris. About 3,900 light years away, a pulsating red hypergiant that was once estimated at over 1,800 solar radii, big enough to swallow everything out to Jupiter's orbit. It's surrounded by a chaotic, lumpy nebula of ejected material that looks less like a dying star and more like a star mid-explosion, because that's essentially what's happening. It is erupting continuously. The jets firing off its surface don't form a clean shell. They fire in random directions, like a fire hose with no one holding it. VY Canis Majoris is a mess, a beautiful, terrifying, enormous mess. And it is not the largest star we found, not even close. Every star I've named so far, warm-up act. Because buried inside one of the most crowded, chaotic star-forming regions in the entire galaxy, 20,000 light-years away, partially hidden, easily overlooked, there's something that made astronomers do a double take, and then a triple take, and then quietly rewrite the textbooks. The star is called SMSSJ 214956-67-604171.0. It was identified as part of a deep survey of the southern Milky Way, a systematic sweep of regions where stars are still being born in enormous numbers. When researchers isolated this object and calculated its properties, its luminosity, its temperature, its distance, the number that came out for its radius was so large that the first instinct was to check for errors. It clocked in at over 2,000 solar radii. That is a radius of roughly 1.4 billion kilometers. To give you that in terms you can actually picture, if this star were placed at the center of our solar system, you would have to travel to the orbit of Saturn with the rings, the planet that takes 29 years to complete a single loop around the sun before you broke through the surface into open space. The entire inner solar system, gone. Jupiter, gone. Everything you've ever learned about the planets, dissolved into the outer layers of a single star. What makes this discovery genuinely unsettling isn't just the size, it's the implication. Stars this massive aren't supposed to stay stable for long. The radiation pressure they generate is so extreme that their own cores are fighting to blow them apart, and yet here this thing is, existing, shining, pushing the upper boundary of what stellar physics says should even be possible. Its luminosity is already sitting above what was once considered the theoretical maximum for a star. It is not just breaking the record, it is questioning whether the framework we use to set records was ever complete. Here's the thing that should stay with you. We almost didn't find it. It sits in a region of sky so dense with stars that individual objects get lost in the noise. It took a specific survey, a specific instrument, and someone specifically looking in that direction to notice that one of these lights was different, that it was impossibly bright, that it wasn't fitting the pattern. We have mapped less than 1% of the observable universe in the kind of detail that would let us find something like this, which means the question is not whether there are larger stars out there. The question is how many of them we've already pointed a telescope at and simply didn't notice. If this broke something in your brain, good. Drop a comment. Tell me which part hit hardest. And if you came here wondering what the biggest star in the universe was and you're leaving with more questions than answers, honestly, that's exactly how it should feel. Subscribe if you want more of this. There is no shortage of universe left to cover. I'll see you in the next one.